Here we're going to look at an example of a geologic sequence in order to get more comfortable with putting events in order from oldest to youngest. But before we get to the sequence, we have to remember that sedimentary rock layers have very specific map symbols, as you can see in the image. And if you remember, on page 7 of your Earth Science reference table, when you have the diagrams for your sedimentary and metamorphic rocks, the map symbols are provided and the names of those rocks are also provided. So you're able to see the map symbol associated with each specific rock, which is going to be very useful throughout this unit. So before we begin the sequence, we need to remember the law of superposition, which states the oldest rock layers are near the bottom and the youngest rock layers are at the top. So to start off with that bottom layer, that's going to be sandstone. So we started off with the deposition of sandstone, followed by the deposition of conglomerate. After the conglomerate, we had the deposition of shale, followed by the deposition of limestone. Now, if we look at the 4 of these layers, you'll notice that they're not perfectly horizontal. According to the law of original horizontality, rock layers are deposited in horizontal layers. If they're not horizontal, something must have happened to disrupt them. These layers have undergone something called folding. These layers are folded, no longer horizontal. When you have folding, that means mountains are forming. You also have something called uplift, where that land is pushed higher up into the atmosphere. As a result of that, you have a layer here that I've outlined in green, which shows that part of the rock layers have been they've disappeared. They're incomplete layers, especially that limestone and that shale, because after that uplift, you're exposing those rocks to the environment and they undergo weathering and erosion. Now, in order to form rock layers on top of this, in order to get the deposition, you need something called subsidence. Think of the first 3 letters of that word, sub. And submarine means a boat that goes under water. So subsidence is when those rock layers also go underwater below sea level, and that allows for more deposition to continue. So after the subsidence, then we had the deposition of that limestone layer, followed by the deposition of that shale layer at the top. However, we are not quite done yet, because if you look at this layer of shale, you'll notice that it is not fully complete. There are parts that are missing, because once again, when you're exposed to the environment at the top, you can undergo weathering and erosion, which can erase some parts of the layer. Here's one more example of geologic sequencing, and right off the bat we can notice that this is different because we see that there is a fault line XY due to an earthquake. So we're going to see how that impacts our sequencing in a little bit. But first we have to start off by naming the oldest layer. So again, according to the law of superposition, the oldest layer is going to be on the bottom, which is going to be conglomerate, followed by the deposition of your limestone. Then you get the deposition of sandstone, followed by the deposition of your shale. Now those first 4 layers were all impacted by the fault line XY, which is your earthquake. If you look at the 2 layers C and D above, they were not impacted by that earthquake. Just the bottom 4 layers were, which means that earthquake had to happen next. You'll notice that on the right side of the fault line, the rocks were shifted downward, and on the left side, those rocks were shifted upward. The earthquake disrupted those layers, which means they must have been there first. The earthquake came after. This earthquake led to some uplift, which pushed that land up and exposed it to the environment. And when you do that, you have weathering and erosion, which takes some of those rock layers and erases them away. After your weathering and erosion, above that you have layers C and D. So you have the deposition of layer C, which is your sandstone, followed by the deposition of layer D, which is your shale.